In March 2025, amidst the silent expanse of space, Europa Clipper's radar bounced signals off the Martian surface during a critical in-flight test, a rehearsal for the icy barriers of Jupiter's moon, Europa. This successful operation signals a potential breakthrough in our quest to uncover hidden extraterrestrial oceans. As Europa Clipper soared past Mars in March 2025, its radar system, REASON, Radar for Europa Assessment and Sounding, Ocean to Near Surface, demonstrated a stunning capability that could redefine our search for life beyond Earth. Deploying sophisticated radar technology, REASON transmitted high-frequency radio waves and received clean echoes from Mars, a deep space end-to-end validation of hardware, software, and data processing meant for Europa's ice. This radar test was not just a routine procedure. It was a critical demonstration of technology designed to explore subsurface oceans believed to exist under Europa's frozen crust. The data from the Mars flyby was a game-changer. REASON successfully captured a long radar profile of Martian terrain and enabled teams to fine-tune processing for Europa observations. It provided unprecedented detail for an in-flight test of this kind, returning a large dataset and revealing clear structure in the echoes, valuable practice for interpreting complex signals in ice. This success points to the potential of detecting and mapping structures within Europa's ice shell and identifying internal water pockets, offering a tantalizing possibility of finding habitats suitable for life. The significance of this radar test extends beyond technical achievement. By confirming REASON's capabilities, the mission team is now more equipped than ever to tailor subsequent phases of the Europa Clipper mission. Understanding the thickness and composition of Europa's ice shell will guide the spacecraft's trajectory, ensuring it optimizes its scientific returns after arrival at Jupiter in 2030, when Europa flybys begin. The Mars test also helped refine the radar's algorithms and processing techniques, essential for deciphering the complex signals that will come from Europa's more challenging environment. Looking forward, the implications of this successful test are immense. If REASON can reveal the architecture of Europa's ice and pinpoint places where liquid water may be near the surface, it will open new doors for astrobiology. Finding water is a key step toward finding life, and this test strengthens confidence that we have the right tools for the job. Scheduled for detailed surveys once the mission begins its Europa flybys in the early 2030s, Europa Clipper aims to map the Moon's ice shell and characterize the underlying ocean environment, seeking chemical clues of habitability and venturing into an alien world that may parallel early conditions on Earth. With the radar's capabilities now proven in flight, the scientific community and space enthusiasts alike are on the edge of their seats. What secrets lay beneath the icy surface of Europa? Could this distant, frozen world host environments where life might thrive? The answers to these questions lie within the capabilities of REASON, and the successful Mars radar test is a beacon of hope. It marks a pivotal moment where our technical aspirations align with the profound quest to answer one of humanity's oldest questions. Are we alone in the universe? As Europa Clipper prepares for its journey deeper into the outer solar system, it carries not just the hopes of planetary scientists, but the collective curiosity of us all, standing by to peer beneath the ice into potentially habitable worlds beyond our own. With the Europa Clipper mission launched in 2024, NASA's Radar for Europa Assessment and Sounding, Ocean to Near Surface, REASON instrument, is at the heart of our quest to unveil the icy secrets of Jupiter's moon. REASON, a dual-frequency ice-penetrating radar, is designed to probe Europa's thick crust of ice, potentially up to tens of kilometers deep, laying bare the mysteries that lurk beneath. This sophisticated tool will map the ice shell and, most importantly, identify liquid water reservoirs within the ice. These subsurface environments are prime targets in the search for extraterrestrial life, as they likely provide the stable liquid settings necessary for life to emerge. Dr. Donald Blankenship, a leading scientist on the instrument team, explains that the chemical interactions between rock and warm water on Earth are central to the emergence of life. By employing similar principles, Europa Clipper's instrument suite aims to detect signatures relevant to habitability within Europa's system. REASON's capabilities don't stop there. It will scrutinize the icy surface for signs of recent or ongoing activity and possible water vapor plumes, first suggested by Hubble observations from 2012 and followed up in later years. Hint that Europa's ice may be thinner in some regions, allowing ocean material to reach near the surface, an easier target for future sampling. The implications of REASON's findings extend beyond the search for life. Understanding the thickness and distribution of Europa's ice can reveal much about the Moon's geological history. Patterns in the ice, detected by the radar, can show how the shell has shifted and changed over time, pointing to tectonic-like activity. This geologic dynamism is a key component in the theory that life on Earth originated near hydrothermal systems on the ocean floor, energized by water-rock interactions. If Europa exhibits similar processes, the chances of life having emerged there increase dramatically. Moreover, REASON is expected to provide insight into vertical layering within the ice, identifying strata that have built up over millennia. These layers act like a tape recorder, each one capturing a snapshot of the environmental conditions at the time of its formation. Analyzing these layers could allow scientists to construct a timeline of Europa's climate history, offering clues about periods when the Moon might have been most habitable. As we gaze into the depths of Europa's ocean, the real question remains: how do we determine its potential for life? This isn't just a matter of detecting water or ice. It's about understanding the complex interplay of chemical and geological processes that could create a habitable environment. With REASON providing unprecedented data about the ice shell and other instruments, like the magnetometer investigation and plasma measurements, constraining ocean properties such as depth and salinity, we're not just looking for an ocean, we're assessing whether it could support life as we know it. The implications of such a discovery would redefine our place in the cosmos, marking a monumental leap in our understanding of life's potential to emerge in the universe's far-reaching corners. The quest for alien life hinges significantly on proving the habitability of celestial bodies like Jupiter's moon, Europa, where conditions might not just be right for life, but where life could currently thrive. Europa's suspected global subsurface ocean, supported by strong geophysical evidence beneath a chaotic, frozen crust, meets several essential habitability criteria. It has water, a source of chemical nutrients, and energy sources. Notably, the REASON instrument will collaborate closely with other tools aboard Europa Clipper to assess the thickness of Europa's icy shell, while complementary instruments investigate the composition of surface materials and any material vented into space. This multi-instrument synergy enhances our ability to not just imagine, but robustly analyze the habitability potential of Europa. The implications of these investigations are monumental. Should Europa Clipper confirm the presence of an environment conducive to life, it would not only support the theory that life can evolve in varied conditions, but also likely catalyze a new era in astrobiology, focusing on life detection and analysis beyond Earth. Researchers emphasize that Europa may hold the clues to one of NASA's long-standing goals, determining if we are indeed alone in the universe. Ongoing studies into Europa's geophysical dynamics support the potential for active geological and possibly biological processes within this alien ocean. Looking ahead, the findings from Europa Clipper might influence future missions, including potential landers or even probes designed to access near-surface water for direct analysis. These missions would be equipped to look not just for signs of habitability, but for life itself, employing even more sophisticated instruments capable of detailed biochemical measurements. The anticipation surrounding these prospects is palpable. Europa may well be the place where we first discovered life beyond Earth. With the combined efforts of Europa Clipper's suite of instruments, our understanding of life's possibilities beyond Earth continues to expand. This mission does not merely seek signs of ancient habitats, as has been the primary focus on Mars, but rather it aims to assess a potentially active ocean world. The implications stretch far beyond academic curiosity, touching on philosophical and existential questions about our solitary status in the universe. As these missions progress, humanity inches closer not only to answering the tantalizing question of whether we are alone, but also to understanding the broader cosmic conditions under which life can flourish. Europa Clipper's journey past Mars was not just a simple test. It was a gateway to potential worlds of water hidden beneath ice, challenging our perceptions about life in the universe. As we prepare for the revelations from Jupiter's enigmatic moon, we stand on the brink of possibly rewriting the biological narrative of our solar system. If you enjoyed this story, hit subscribe for weekly deep dives into space science. Thanks for watching.